Okay, so this is problem number 6. The acceptable level for insect filth, gross, in a certain food item is 2 insect fragments, larvae, eggs, body parts, and so on per 10 grams. That's great to think about there being insect parts in your food, isn't it? All right, simple random sample of 50 10-gram portions, so that's our little n, of food items is obtained and results in a sample mean of X bar 2.6 insect fragments per 10-gram portion. All right, so first question is, why is the sampling distribution of X bar approximately normal? And so it is approximately normal, and it's because of the good old central limit theorem. Says that if we were to get enough of those X bars, right, if you were to graph a distribution of the X bars, then they would be approximately normally distributed. And this will work anytime, our rule of thumb is anytime your sample size is greater than 30. So in this case, our sample size is 50, so we're large enough that it'll work. So some of these answers are kind of funny. Like this one's normal because the population, well, we didn't know that the population was normally distributed. If it was, that'd be great, but we didn't know that. So the second one, it's normal because the population is normally distributed. We didn't know that. They didn't give us that information. C, it's normal because it's normal. We assume it's normal. Well, we try not to assume, so it's not that one. And then D, it's because the sample size, 50, is greater or equal to 30. So we're good there. So our answer is D as in dog. So hello, best. All right. So what is the mean and standard deviation of a sampling distribution X bar with mean 2 and standard deviation square root 2? Okay, so I went ahead and wrote it out here for us at the side. The mean of X bar is going to be the same as the population mean always. That's always true, and so that's 2. And then the standard deviation of X bar, the formula for that, for the sampling distribution is the population standard deviation over the square root of the sample size n. So that's the square root of 2. In this case, our sample size was 50, and this comes out to be 0.2. So it says round to 3 decimal places as needed. We didn't need to round it. All right, so part C, what is the probability a simple random sample of 50, so our n is the same, we don't have to adjust our mean or our standard deviation, portions of the food item results in a mean of at least 2.6 insect fragments. So we're looking for the probability that X bar is greater than or equal to 2.6. So we're going to do normal CDF, where if it's greater than, we're doing negative, sorry about that, we're doing 2.6 is our lower bound, our upper bound out to infinity would be 1 times 10 to the 99. Our mean is 2, and our standard deviation is 0.2. We're going to put that in our calculator. Okay, and that comes out to be 0.0014999672. So to 4 decimal places, 0.0013. So is this result unusual? Yes, it is unusual. So this is not unusual. Not unusual. How did you know, Miss Benton? Because 0.0013 is less than 0.05, 5%, right? This is 0.13%, which is less than 5%. And so because the probability is large, no, because the probability is very small. So this would be D as in dog. All right, what might we conclude? Okay, well, these are both not unusual, which we said it is unusual, so it's got to be either C or D. And so our choices are the mean is higher than 2 or the mean is higher than 2. Oh, it's not reasonable. Here's the difference. Not reasonable versus it is reasonable. And so it is unusual, sorry, to assume that the mean would be higher than 2. Think about it like in your tails. Here is point, what was our number again? 0.0013, and then our mean was 2, right? And so it's way out here in the tails. So the probability is that it would be higher than 2, which is C as in cat.